Hello. As you can see, the topic of discussion for the day is similarity. This is not similar behavior of two different people. This is not about similar taste of food. It is not about having similar inclinations. This similarity is basically about having similar kind of shapes or similar kind of structures. But where is this coming from? Are we going to study this only because it is given in the textbook? That's not an interesting reason, as I can say, I find things interesting or fascinating only when this particular or any particular topic is a part of my life, is a part of my observation, is a part of my study. If that is so, then I can take notice of that. And with that, we can study and actually we can discuss this. Now we know that similarity has not been a part of our life, or at least it appears that it was not a part of our life. But somebody must have noticed it. Somebody must have checked it. So we'll now see where do we find similarity. This is about similar shapes, or basically it is basically about similar triangles. So where do we find similar triangles in our life? Let's see. We'll begin our journey about similarity and similar triangles with a small story that we'll introduce. Let's see the story. A man with his son is coming out for a walk. It is early in the morning, the sun had just risen. The sun is still lingering around the horizon. The rays of light are not exactly parallel to the ground, but they are making a very small angle with the ground. And the man is walking. Let's say this is the man. And with him is his son. The height of the son is actually absolutely half of the height of his father. If his dad is 6 feet tall, the son is 3 feet tall. We are not talking about a very small child or anything. Son is, let's say, is about 8-9 years old. Now what happens is, because of this sunlight, a shadow is cast, and the shadow is very long. It is as expected because the sun has just risen, so the sun is very close to horizon. As a result of that, the sun rays are coming, making a very small angle with the horizon or the horizontal surface. So what happens is, even the sun's shadow will be really long. The son gets very excited because he's seeing such a long shadow. In all his life, he's seen the longer shadows belonging to other people. Every time there is a long shadow, the shadow is of someone else, always. Because it's still a kid. But today, early in the morning, the sun being so close to horizon, just risen, the sunlights, the sun rays are so, almost parallel, not parallel, but making a very small angle with the horizon. As a result of this, the shadows are really long. And the son is really excited. My shadow is so long, he says. Dad says, my shadow is still longer. And the son agrees. It is true. Dad's shadow is still longer. But it's not just about longer or shorter. Then the son walks back and he stands right with his father. I'll draw this, a line very next to his father here. You could assume that the son is actually very coinciding, almost completely coinciding with his dad. But I cannot draw this because the two lines will merge and will not appear to be different lines. So I am drawing a line next to this. And this will be the shadow of the sun. So the length of the shadow for the sun is this. and the length of the shadow for the father is this. Dad's shadow is twice as big as mine, says the son. He's right. Dad's shadow is double in size. Obviously, because dad is double in size. As far as the length is concerned, the height is concerned, dad is surely double in size. The shadow is also double in size, in length. So this is a normal observation very early in the morning when these two are walking, just having a morning walk. The sun is making very small, the sun rays are making, sunlight is making very small angle here. But the son observes that dad's shadow is double the size of my shadow, or the sun's shadow in the sense. But when they are coming back, the sun has already risen a bit. So it's not that the sun is really, making such a small angle now. After an hour or so, the sun is risen pretty high. As a result of that, if the dad is standing here, let's say, and the sun would be standing here, then dad's shadow will be here. I hope you understand this. It was initially here, but the sun has risen. The shadow comes here. For the sun, the shadow is here. Again, this and this. The sun sees that now the sun has risen, and because of the rising sun, the sun rays are not coming, not forget parallel, they are making a larger angle with the horizon now. They are actually now starting to grow vertical, the sun rays. But here, the sun rays are such that the length of the shadow has reduced for both the father and son. The father's shadow is this, length of the father's shadow is this, and the length of son's shadow is this. But even in this case, if the son's shadow is x in length, the father's shadow is 2x in length. Now, this is a very interesting observation. The son says that because of the sunlight, initially the shadows were larger, but your shadow is double my size. But now the sun has risen much higher, and the length of the shadow is reduced. But even now, your shadow is double my size. And dad says yes. His father says yes. This is happening because my height is double your height. Dad's height is double the son's height. So even if the angle is changing, with this angle made between the sunlight and the horizontal ground, if this angle is changing, the length of the shadow will keep on changing. If the sunlight comes here, the angle will be much different. The length of the shadow will be changing. But the ratio of length of shadow for father to the length of shadow for the son, this ratio will remain constant. This is the interesting observation. And this observation is brought out by the son, and he is saying that to the father. And the father says, we'll talk about that when we reach back home. This is where the similar triangular similarity comes into picture. We'll see that. When both father and son reach home, they sit at the dining table. The father is having his cup of coffee. The son is having his glass of milk. They are waiting for the breakfast to arrive. And in the meantime, the father takes out a paper and draws a small diagram. What is that diagram? And what does that father has to tell to his son? Let's see. On the paper, the father draws this small diagram. He's saying that this is father. And this is the sunlight. So the shadow is so long. But as we can guess, the son is standing right next to the father, and even his shadow is long. Please don't mind my drawing skills. I barely have the ability of drawing straight line, but you can understand this. So what happens is, let me just please correct this. So the shadow of the father is reaching here. This and this. This and this. Now the father says, please note this, sir. This is what happened when we were going for the walk. Early in the morning, when we were going for the walk, the sun had not risen far. So as a result of that, the sunlight was making a very small angle with the ground. And because of the sunlight coming not overhead but almost parallelish, as a result of that, the shadows were very long. The son chips in saying, yeah, but even then your shadow was double that as compared to my shadow. And father says, yes, if this is your shadow, x, then this distance is also x because the total length of father's shadow is 2x. And we are assuming they are standing at the same point. Then the father draws one more diagram and he says, this is what happened when we were coming back. Same height roughly. Horizon. The sunlight. This is the sun standing here. This is the shadow. So as a result of that, if this is y, this will be y as well, because the length of father's shadow will be twice y, twice of this sun's shadow. And the dad is saying, even if this angle is small like it is now, or if this angle is large, or some other day we could be walking out very close to the moon, let's say at 11:30 or 11 o'clock. 11 o'clock in the morning, the sun will be almost overhead and the sunlight will be coming like this, not even like this, like this. But even then, with the child, the son standing right next, his shadow will also be right midway. So this small distance is half of this distance. The shadow of father is double the size as compared to the shadow of the son. No matter what this angle is, the ratio of this and the ratio of this ratio and this particular, this distance and this distance, the ratio is always 2. The length of the shadow for father, the length of the shadow for the son, the ratio is always equal to 2 because their heights are in that proportion. The son is very curious and the father is saying, now listen to this carefully. We have this right angle triangle where this is height, father's height. This is length of shadow for the father. But here the sun can be also standing next and the sun will also have a shadow. So small h is the height of the sun and small l is the length of the shadow for the sun. So the father is saying that if capital L is the length of the shadow of father and capital H is the height of the father, small l is the length of the shadow for the sun and small h is the height of the sun, then no matter what the angle made by the sunlight with the ground, no matter what time of day, no matter where the position of the sun is, no matter how steep or how flattish do the sun rays appear, the length of the shadow will always have the same ratio as the height of the people. So capital H upon H is equal to capital L upon L. This will never be disturbed. And then the dad says, you know why this happens? This happens because if this angle is theta, then even this angle is theta. How come? Because we know that the sun rays are going to come parallel to each other. If this sun ray and this sun ray, they are obviously parallel to each other. And this line is intersecting two parallel lines. So these two are corresponding angles. I hope you understand this. These two parallel lines, intersecting line is this. These two angles will be corresponding angles. So this is theta, this is theta. This angle will be 90 degree for both father and son. They are standing upright. So the angle between their height, because they are standing up upright, and the horizon, the angle between them will be 90 degrees. So this is the right angle. Clearly the third angles will also be equal. Even this angle and this angle will be equal. Even these two are corresponding angles, you can see. So what is happening is, in this triangle, now let's see, we'll just label these triangles. So the larger triangle, this is A, B and C, and this is P, B and Q. The bigger triangle represents the height of the father and the length of the shadow of the father. The smaller triangle is representing the height of the sun and the length of the shadow of the sun and corresponding. No matter what the angle is, but these two angles will always be equal because these are sun rays coming parallel. And because the sun rays are coming parallel, even these two angles will also be equal, and this angle is obviously equal in 90 degree. So these three angles are equal for both the triangles. And in that case, we say that in triangle ABC, in triangle ABC and triangle PBQ, angle B is equal to angle B is equal to 90 degree, because this is the angle between the horizontal surface and the vertically standing posture of the people. The angle A is equal to angle P. This is again corresponding angle, is very obvious. And angle C is equal to angle Q. It is also very obvious because these two are also corresponding angles. So if all three angles are same, then the triangles are called as similar triangles. And we write it like triangle ABC is similar to triangle PBQ. Please note that we are not saying that the triangles are congruent. They are not congruent, because congruent triangles have equal distances or equal sides. If this side and this side is equal, then the father and the son have the equal height, which is not true. In our example, at least it is not true. So we are not talking about two triangles which are congruent. The triangles are not congruent. If they are congruent, what happens with the congruent triangles is, if I could cut out this triangle, then this triangle can be superimposed on the triangle ABC. Then these two triangles must completely match. But these two triangles will not match. PBQ, this triangle, even if I cut it out, and ABC, even if I take it out, these two will never perfectly match, because if we match the point B, then this vertical line A will go up to A, but for the second triangle it will end at P. This side and this side will never be equal. This side and this side will never be equal. This side and this side will never be equal. So the sides are not equal. But the angles, all the angles are equal. Now we can recollect this. If this is a square and this is also a square, then we say that these two things are similar in shape. All sides equal and all angles 90 degrees. then these two are similar in shape is what we say. But they are not similar in size, because the size of this and this is different. This size is different. The size is different, but the shape is same. So they are similar in shape, but not in size. These two triangles, ABC and PBQ, are two different triangles similar in shape, but not in size. But because they are similar in shape, we can just stretch it and it will be stretched and magnified in such a way that everything will match with each other. So if we just enlarge this triangle PBQ, if we use a magnification and we magnified it twice, then this height will match with AB. This length of the shadow will match with Q's BC. And this will match with AC. So these two triangles are, it is just that if we can multiply every side by a constant factor, then these two triangles will become congruent. Because the angles are already equal. It's just the sides are not equal. So in that case, what can we say is, every side of this smaller triangle is equal to a fraction multiplied by every side of the larger triangle. In this case, that fraction is half. Height of the sun is half of height of the father. Length of the shadow of the sun is half of length of the shadow of the father. And this distance is the distance traveled from head to the shadow by the sunlight. This distance from head to the shadow, to the point of shadow, to the head tip of the shadow, from head to the tip of the shadow. This distance traveled by the sunlight, this distance for the sun is half as compared to the same distance for the father. Then we realize that if the two triangles are similar, then their corresponding sides are proportional to each other. So we can say that AB upon PB is equal to BC upon BQ is equal to AC upon PQ. This is called as similarity or similar triangles. The concept of similar triangles is those triangles, any two triangles that you take, if all the angles of one triangle is perfectly equal to all the angles of the second triangle. I am not talking about equilateral triangle where all angles are equal. No. The triangle can have any shape, but each angle, all three angles, are perfectly equal to the three angles of this triangle as well. They are matching in pairs. They may not be equal, so it is not 60, 60, 60. But you can imagine 30, 60, 90. Let's say this is 30 degree, this is 60 degree, this is 90 degree. So even here it will be 30 degree, 60 degree, 90 degree. So if all the angles of one triangle is equal to the corresponding angles of the next triangle, then these two triangles are said to be similar. And for similar triangles, the ratio of sides is equal. All the corresponding sides are in proportion, they are proportional to each other. So the ratio of the sides will be equal. This is what similar triangle is. In our next class, I'll tell you how this understanding of similar triangle has actually been the standing stone or the stepping stone for the understanding and invention of trigonometry. I hope you enjoyed this. Thank you.